But at least one more world leader would fall victim to his unabiding obsession with large cannons. Before he gained international recognition as a Middle East strongman, former Iraqi leader Saddam Hussein was intrigued by the idea of having a supergun, a cannon so large that he could fire it into space. In 1989, Hussein met a Canadian-born astrophysicist named Gerald Bull, and their joint vision began to take shape. Ever the bully, Hussein wanted to aim his supergun at his Israeli neighbors.
The problem with that was, well, several problems. One, it was fixed in a position. So how many rounds are you going to be able to fire before the Israeli Air Force, which is a very good Air Force, finds the gun and bombs it into about 8 million pieces?
Because the supergun was so large and shrouded in secrecy, it was shipped in sections from England, where it was built, to Iraq under the pretense of being petrochemical pipes. When complete, the cannon would be a nearly 200-yard-long supergun, firing a 600-kilogram projectile, roughly 700 miles. The components for the cannon came from factories in England, Spain, Holland, and Switzerland. Unfortunately for Hussein, British customs agents seized the final 8 sections of the supergun in November 1990, before it could be finished. While Saddam Hussein won't be harboring dreams of a supergun anytime soon, the United States continues to upgrade its cannon technology. New cannons for possible future wars will be produced in the same place they've been produced since 1813, Watervliet Arsenal near Albany, New York. Watervliet is the oldest continuously active arsenal in the United States. It is the only arsenal in the country making large caliber cannons for today's military.
We're not here to build and produce a piece of metal that just goes and sits somewhere. We're here to build a cannon, an artillery piece that will work, that will protect us and our soldiers, and also not malfunction.
The process of manufacturing today's cannons is a continuation of the art form started in the 13th century.
The rotary forge is set up so that you take a preform of this gunmetal steel, which is maybe 8–10 feet long. We take that and we put it into an induction furnace that heats that preform up to about 2,000, 2,100 degrees.
After it's taken out of the furnace, the barrel travels on a conveyor belt toward the rotary forge.
This huge cannon will begin to turn and move into the jaws of the rotary forge. The rotary forge has 4 large hammers, and those hammers are controlled by a computer control room.
The size of the cannon barrel determines how much force the hammers will use to shape the barrel.
Anytime you heat up steel, you lose some of its properties. So what you have to do is heat it up again and instantly cool it. You'll put it through this annealing process, which, if you cool it instantly, it returns all of its metal properties to it.
This entire process takes about 15 minutes, down from the 15 hours it took only 20 years ago. The U.S. Navy is also taking advantage of improvements in cannon technology.